Hello and welcome back to my channel. In the last video we have learned support vector machine. In this video we are practicing SVM in Python. So without further ado, let's get started. Now let's import the libraries. Step 1 is importing libraries. Import pandas is pd. So this library is used to handle data in table format. Another is import numpy as np. So numpy is used for numerical operation and grid creation. And another is import matplotlib.py plot as plt. So this is used to create visualization. Another is from sklearn.svm import svc. So this support vector classifier helps build an SVM model for classification problem. Next is from sklearn.model selection import train test split. So this helps to split our data into training and the testing sets. Next is sklearn.metrics import accuracy underscore score. So this will check how accurate are the model's predictions. So this is how we import libraries. And now we are going to create a simple data set of students, and we want to find out whether a student will pass or fail. And our data set will include study hours, sleeping time, pass or fail data of the students. The more they study, there is a high chance of passing. However, if they sleep more and study less, then there is a high chance of failing. So let's write here step 2, creating data sets. Data equals to 1 is we have study hours, and let me give 1 2 3 5 6 7 8 9 and then 10, then comma. Another is sleep hours, nine, 8, 8, 7, 6, 6, 5, 5, 4, 3, and then comma, pass equals to like 0 0 0 0 1 1 1 1 and then 1 again 1. Okay, so this is our data set. Here is study hours, so how many hours the student have studied, and sleep hour is how many hours the student slept, and pass, it will determine whether they pass or not. If it is 1, then yes, and if it is 0, then it's a no. Now let's convert this dictionary into pandas data frame. df equals to pd dot data frame and then data. Okay, next step is splitting the features and the target. Next is step 3. Step 3, splitting features and target. So x equals to df and then study hours comma and then sleep hours. Okay, here x is a feature, that is the input values like study hours and sleep hours. Similarly, y equals to df and then pass. So here y is the target, that is the output label we want to predict, such as pass or the fail. Now let's split the data into training and the testing sets. So step 4, splitting the data. X train comma x test comma y train comma y test equals to train test split and then x comma y comma test size equals to 0.3 comma random state equals to 42 and then close this. So here we have splitted the data into 70% for the training the model and 30% for testing its accuracy, and random state equals to 40 ensures the split is always the same. And the step 5 is creating and training the model. Model equals to SVC kernel equals to linear and then close this, and model dot fit and then x train comma y train. So here SVC creates a support vector classifier and kernel is linear, means the model will try to separate data using a straight line. So this will train the model with the training data, and SVM will try to find out the best line which separates the pass and fail students with the maximum margin as possible. That means the line should be as far as possible. So after training, let's make prediction for the testing data set and find its accuracy. Has step 6 and then making prediction and finding accuracy. Y pred equals to model dot predict and then x test. So here the model predicts the outcomes for the test data, that is x test, and I will print accuracy and then accuracy score like Y test and Y pred. Okay, so this will calculate the accuracy of the model. It compares predicted results Y pred with actual result Y test. So if the accuracy is high, then our SVM is correctly classifying the students. Now let's predict for the new data. Step 7, new prediction. Okay, new data. So I'm giving here new data like 4,6. So here we are trying to test the model with a new student data such as study hour equals to 4 and sleep hour equals to 6. And then I will just prediction equals to model dot predict and then new data, and I will print this like student pass and yes if let me write here, yes, if prediction 0 equals to 1, else no. Okay, so here the model will predict if the output is 1, then it is yes, which means that student will pass, but if the output is 0, then it is no, that means student will fail. And then model will decide based on which side of the decision boundary the point lies in. Another is visualization. So step 8 equals to visualize the decision boundary. Okay, so plot dot figure and then I'll give the figure size equals to 8,6. So here we are plotting the figure. Here 8 and 6 are the width and height of the plot area. And next is plot scatter, like plot dot scatter and then x train and study hour and x train sleep hours, sleep hours, and then y equals to, I will explain this later, y train c map equals to cool warm and s equals to 80 and label equals to training data. Okay, this is the function that creates the scatter plot. We know x train gives the x-axis values, that is study hours, and x train sleep hours is the y-axis value. The color C of each point depends on its class level, example 0 or the 1. Hence, the point belonging to different classes have the different colors. C map equals to coulomb means it defines the color palette, and S equals to 80 is the size of the point, and the level equals to training data gives the level name for the plotted data. Therefore, basically this draws a scatter plot showing student data. Now, another is here x mean comma x max equals to x study hours dot mean minus 1 comma x and then sleep hours dot max plus 1 sorry, here should be study hours. Study hours, okay, max plus 1. Similarly, let me copy this and then I will write here y mean y max x sleep hours dot mean minus 1 x sleep hour dot max plus 1 and then xx comma yy equals to np dot mass grid and then np dot arrange and then x mean comma x max comma 0.1 comma and np dot arrange y mean comma y max comma 0.1 and then this. So this will create a grid covering the entire graph, and each point on the grid will be used to determine if it is pass or failed region. Okay. Next is z equals to model dot predict np dot c underscore xx dot dot reveal and then yy dot reveal okay, this is to predict the class as a pass or fail for every point on that grid. Next is z equals to z dot reshape and then xs dot shape. Okay, this will reshape for displaying as a smooth background color. Next is plot dot contour and then xx comma yy comma z comma C map equals to cool warm, and then alpha equals to 0.3. Okay, plot dot x label equals to study hours, and plot dot y label equals to sleep hours. Okay, I will not give like this. And plot dot legend and then plot dot show. Okay. Okay, now let's run this. Okay, we get the result like this. See, we get the boundary line. The red region depicts the student who pass, that means who studied more and sleep less, and the blue region means who fail, that is the students who studied less and slept more. And the decision boundary here is like 50-50 around. And our new data 4 and the 6 falls just near the border. Since it's slightly towards the pass region, then the model predicts the yes here, and the accuracy is 1, which means the model correctly predicted all the test cases. Okay, this is the example of SVM in Python. I hope you like this video. If you like this, please do not forget to like, share and subscribe my channel. I will see you in the next episode.